I appreciate everybody coming and being willing to listen to me talk about something that's very important to me in the practice of occupational hygiene. I got a little bit about what you said about me in Norwegian, but I am a professor of environmental health at Bowling Green State University. He mentioned the book that the AIHA Exposure Assessment Strategies Committee and the modeling subcommittee. I and some colleagues are listed as the editors, and I've authored some chapters, but this is a real collaboration of everybody that's involved in the modeling subcommittee at AIHA. And if I know that if you're interested in more information, you can talk to me or any of the other people who participated in this book, and they would love to be able to share our passion and desire to have exposure modeling integrated into comprehensive exposure assessment strategies. So I would like to speak this morning on where exposure modeling does fit into exposure assessment. I'll give some examples and some fairly simple examples, and as I ask you that as you see some of these examples, you may say, oh, that simplifies the situation, and it does. In a form like this, it's very basic, but just showing the potential utility of having these tools of modeling to help us understand exposures. So I'd like to start from my perspective anyway of why are we assessing exposures anyway. And I think ultimately, and the driving force to it is exposure assessments are inputs to risk management. And really at the root of it, we're asking what are the health risks of workers that are exposed to a variety of agents in the workplace. This book is primarily on chemical agents, but we can model also and assess exposures to physical agents, biological agents as well. And these are inputs to risk management. We are well aware that management of risks takes prioritization and decision making, and exposure does not equal high risk, but understanding what hierarchy of risks are being presented by the suite of exposures that workers are facing helps us prioritize and manage the resources we have better. So we want to understand what existing exposures are, and what modeling can really help us do is to document exposures when they're acceptable. I have many stories from students of mine who have gone to facilities after graduation, and the previous person who had had a health and safety job there said, oh, we looked at everything and it's all okay. And the question is, how do you know? Well, I use my professional judgment. Well, professional judgment is one thing, but professional judgment when you document, and it may be clear that it's probably a low-risk situation, assessing and documenting that exposure, and hopefully with the help of modeling, can help strengthen the quality of the data and the processes of an organization. So we want to document when they're acceptable. We want to understand when exposures are unacceptable, so some sort of control measure can be put in place, and prioritize for detailed evaluations. And we'll show a couple examples of that. But additionally, we want to start moving into, if we haven't already, doing assessments of potential exposures. Exposures that we should be concerned about, but that there's no way to go out and look at yet. So if there's going to be a new process, I'll give an example of, maybe a simple example of how do we look at the adequacy of existing controls? Or if there's an accident or process disruption, what sort of exposures are likely to result, and should we modify our response procedures? Are there other things we can do ahead of time to mitigate the impact of potential accidents? But in addition to input for risk management, there's a growing need for exposure assessment in the realm of exposure reconstruction. What happened in the past? And there's two main threads for this, and epidemiology being one of them. If we have a cohort of workers that seems to be developing some sort of health outcome, we want to understand the exposures that existed in the past so we can understand the natural history of what might be a disease. And I just got done teaching a occupational epidemiology course, and many of the exposure categorizations are yes or no. They were exposed to machining fluid or they weren't, which is really very vague. And when we're talking about trying to look for causality, we want to have dose response, and we want to have strength of responses more so than just a yes or no exposure, because that really isn't capturing the full characterization of the exposures that existed. And my understanding is this is not as big a piece in Norway as it is in the US, but I'll say a couple times this presentation that litigation is very important in corporate mind frames in the US about what their risks are. So the industrial and occupational hygienists are helping manage health risks to workers, but they're also trying to manage the risks overall to the company, because they become very exposed to problems if litigation develops regarding past worker exposures that led to health effects, if in fact the employer can be shown to be negligent or if there was a third party involved in that. And how that works in the US is a bit complicated. If anyone's interested later, I can talk about that. But we need to understand exposures now as completely as possible to help us with our ongoing risk management. We need to understand exposures that haven't occurred yet but may, and we need to understand exposures that occurred in the past. And we need to switch our thinking, and hopefully many of us have, and it's moving this way in the US, but it's not completely there yet, that exposure assessment is not collecting a sample. Collecting a sample properly and documenting how it was done and understanding the context of that sample collection is part of exposure assessment. But exposure assessment is so much more than collecting a sample. We're talking exposure assessment characterizing, where we see these typical descriptors: the magnitude of an exposure, the duration, how long, frequency, how often, the combined route of exposure. So the body burden of a chemical is developed through inhalation, potentially ingestion, dermal exposure for certain chemicals. And we want to know this overall pattern of exposure. We want to know the distributions of exposures of individuals, or if workers are similar enough, understand the distribution of workers of exposures to a exposure grouping. Now, in the United States, for years, starting with the development of OSHA, there was the compliance strategy of exposure assessment, where your concern was this: if OSHA visits, am I in trouble? So it's very much, OSHA will come in and take one sample, maybe two samples, and you cross your fingers, and you hold your breath, and you hope that those are below the exposure limit. And the strategy for assessing exposure was pretty much exercise in hedging your bets, that you're more likely to be okay when OSHA comes in than less likely to be okay. But it's outdated for a variety of reasons in the US. One is that many companies are becoming progressive in understanding that the true cost of illness and disease to a company, that a healthy workforce is really a profit multiplier. And there's very good business cases that can be made for having comprehensive exposure assessment and exposure controls. But again, litigation is a large driving force for compliance in the United States. There has just been some regulatory changes so that OSHA fines and penalties have been dramatically increased. But until then, some, and perhaps even now, some U.S. companies build in OSHA fines as part of their operating expenses. It was cheaper for them to pay the fine than to have a good health and safety program. Then, with the rise of litigation, even when they weren't worried about, companies were not worried about OSHA's fine structures, they were worried about very large penalties from a judge or a jury, which in practice goes beyond the simple medical costs but goes to damages. So that could be quite extreme. So companies are taking that into consideration when deciding how seriously am I going to take exposure assessment and how seriously am I going to take health and safety. So though you're collecting samples when you're assessing exposure, another piece to collecting the samples that needs to be considered is that you're taking them in a statistically meaningful way, that you can have this data set and really do something about it. You need to have enough samples to describe the distribution of exposures, what's the overall pattern, and while you're collecting the data, have enough supporting data to really characterize the characteristics and conditions of exposure. I've been involved in 2 projects that were filled with frustration because we were one was a former student of mine who was interested in looking at patterns of exposure to isocyanates in a certain sector. And he was a very conscientious OSHA inspector, so he would go out, and there's the form that you have the name, the location, and in the middle of the form there's a section for your pump number, your flow rate, your filter ID. But on top and bottom there are many different codes that are supposed to be filled in: existing ventilation, process of work, observations, and just all sorts of information that's supposed to be recorded regarding that sample and regarding the conditions that led to exposure. Well, he was very conscientious in doing that, and he got access to 200 site visits and sampling, and only his were filled out. So you had all this data with potentially very useful information to characterize what's going on with isocyanate exposure, and you didn't have the supporting data. There's corporate organizations that I've worked for. They say, we have a great database of exposure information. Can you help us statistically model? I'd love to. All it is, date, name, concentration. And that's not enough to do that. Were there spaces on the forms to fill out? Sure. Did the hygienist or technician fill them out? No. That is what you're doing is when you're reverting to the old compliance strategy. But statistically meaningful data sets mean that you're allowed to actually do some very simple statistical modeling with some very basic data sets. So an example I'll give here is that you can predict with a very simple statistical approach how often exposures are going to be over an exposure limit, even if you don't measure anything above the exposure limit. So for example, you have a collection of workers or an individual worker, and you are worried about the exposure of this worker. So you take 4 different random samples on this worker or this group of workers. And the exposure limit is 5. And you take 4 samples, and they're all below the exposure limit, and some of them less than 20% of the exposure limit. If you're not aware of the potential ways to interpret and extrapolate this information, you may think that you have no problem. But that may not be the case. So what this is a simple example of a probability plot, where here's the data points that were collected, all below the exposure limit. And we draw a line through them suggesting the trend or the distribution of, if you were to collect more and more data points, they would fall on this line. Here is 5 ppm. You take this up and over, it actually looks like although all the samples you collected were below the exposure limit, potentially 15% of all exposures are going to be above the exposure limit. And that, in many cases, would be unacceptable for an organization. But if you collect the data in a way that is random, that's statistically meaningful, even with a few data points, you can start making choices and seeing trends that will help you prioritize your control efforts. So what about other kinds of exposure modeling? That's a very simple statistical model. What I tend to do is physical chemical modeling, where I look at the properties of the chemical, I look at the conditions of the chemical use and the processes involved, and the indoor ventilation system to predict what concentrations are. And exposure modeling is a great support for monitoring. When you have few data points, it will really help you strengthen decisions you can make based on few measurements if they are supported with appropriate exposure modeling. And it can then help you prioritize. We have 1,000 different exposures at least in every factory that we're worried about. Which ones do we look at first? Which ones do we postpone looking at? Which ones are we comfortable with? We can look at these and help prioritize our efforts by using modeling. And as I mentioned, we can get information about potential exposures, historical exposures, or potential future exposures. So I give a simple example that, a portion of example that I gave in the workshop that we just did. This is a project I was involved in at my university. And this is an organic chemistry teaching lab where faculty and students were complaining of odors during a variety of different chemical exercises. It's a very full lab. You have 1, 2, 3, 4, 5, 6 sides of benches, and each side has 4 students in it. So you could have 24 students in there at a time. There were actually 3 different lab exercises that complaints were arising from, and I'm just giving an example of one. But the lab had 4 supply air diffusers, 6 hoods, and a volume of almost 300 cubic meters. So there's a floor plan layout. Hopefully you could see that from the image I gave. And most of the hoods were these auxiliary air type of hoods where, in addition to the room air, there was a supplied curtain of air to help keep contaminants inside lab hoods. Now, just an operational problem is if you have 24 students doing an exercise and you have 6 lab hoods, that would get very tight as well. But that's another portion of the assessment. So we looked at an exercise in which they're using ethyl ether to do some extraction. Each student was given 17 milliliters of ethyl ether. 17 milliliters, the density is 710 milligrams per milliliter. There's 24 students. So during this lab, there are 290,000 milligrams of ethyl ether out there in the laboratory. So our first approach to saying this was very straightforward. What would happen if in this lab, for some reason, all the ventilation went off? And for some reason, all the students decided to spill the ethyl ether at once. This is clearly a worst-case scenario. No ventilation, it all evaporates at once. Is this something I need to be concerned about? It's not likely because the ventilation isn't going to go off. And just from experience, we know, in talking with the instructors, we knew that most of these students would bring back large portions of the ethyl ether when they were done. So this is really kind of an absolute worst-case scenario. So if I have this 290,000 milligrams, and I had the volume of the room that's almost 300 cubic meters, if that were to happen, the concentration in the room would be 980 milligrams per cubic meter. The TLV is 1,210 milligrams per cubic meter. Am I going to be concerned about this? This is really an absolute worst case. This became very low priority as far as concerns went. And it also became a very useful tool because by doing just some simple math, we were able to go to the instructor and say, it smells bad and students are complaining, but here's what could possibly happen. And the instructor said, that makes me feel much better. When you smell it, you have no idea, your nose isn't calibrated. Your nose isn't calibrated, and chemists don't know what a TLV is, by and large. So this was a way that we could document that there was low exposure, resolve it, get the actual supervisor on board, and he was able to communicate this with the other students. What about potential exposures? That's an exposure that was existing and occurring a couple times a semester. So what if you want to install a new process and ask, is the existing ventilation adequate? I've got an industrial space and an old process went out, a new process I want to bring in, and the ventilation exists already. Is that enough? And again, what about disrupt conditions or accidental releases? Will the in-place controls, will the existing controls protect a worker's health? So here's another example. A degreasing step needs to be added to a process prior to painting the parts. Parts would be coming off of a machining line that has machining fluids on them, and they need to be degreased. So Stoddard solvent is suggested for manual wipe down of metal parts. Take solvent, put it on some sort of cloth, wipe down the parts. Parts go to the painting step. Oh, I changed something up. Where that says 3.0, pretend that says 2.0. But a similar process at another facility goes through, I think, 2.0 liters of Stoddard solvent during an 8-hour shift. And the local purging flow, I think I changed that too, but the local purging flow can be known. So the numbers actually I used here was a 2,000 milliliters of Stoddard solvent for 8 hours and 9.5 cubic meters per minute. But if you have 2,000 milliliters evaporated over 480 minutes, using the density of the Stoddard solvent, we can find out that a little over 3,000 milligrams per minute are released into this volumetric airflow rate, and a concentration would be about 340 milligrams per cubic meter. TLV is 575. It's approaching that. I'm not super concerned yet. I'm not going to dismiss it, though. Then you start considering the other aspects. Well, is it going to be higher, closer to that worker? Is it going to be, is it something the worker is going to be exposed to continuously? But we can get some idea of the existing ventilation rate. What are the resulting concentrations here that we can expect? And what about exposures that occurred in the past? So if there's an accidental exposure, we have no chance to monitor. Or we have workers that were exposed a decade or more ago. So through litigation or epidemiology, we want to have some estimate of what their exposure might have been. If that's the case, maybe you can go there present day and see what the exposures are. But really, if it's a decade-old process, is the process still the same? Is it still being done the same way? Are the same raw materials being used? And in many cases I've been involved in, does the same process exist at all? I've been involved in legal cases where we would go to the space where the workspace where exposure occurred in the early 80s, and it's an empty room. You can't try to get a measurement of existing conditions. And as I've alluded to before, historical data often has few samples, if any, and it's often poorly documented. You know, again, this in some litigation I've been involved in, a company actually had exposure measurements collected on a worker in the early 80s. The worker developed leukemia later on. But again, all that had was the name, the date, and the exposure level. And sometimes they were very high, and sometimes they were very low. And the company said, well, when they're very high, the high ones, we were doing assessment during a high-risk procedure, so there's a lot of high ones because we were only measuring worst case. And the plaintiff's attorney said, oh yeah? Show me. How can you prove that? It wasn't documented very well. So document. So here's an accident that happened, okay? A worker, like my graphic arts, it's high quality. My daughter does great 3D graphic design, and I can't get her to help me. But in this case, a worker opens up a storage cabinet that had an open bottle of heptane in it. They take what they described as 2 breaths. I say took 2 breaths, stepped back, and I had to sit down, and I don't know what happened. Okay. The occupational physician wants to know, well, what was he exposed to? I don't know. Well, you can make some assumptions that if this was open long enough that you had saturation concentrations inside that cabinet. So the concentration was about 217,000 milligrams per cubic meter. The tidal volume is half a liter, and he took 2 breaths. He inhaled 1 liter. So his dose was about 215 milligrams. Now the doc can say, well, how much was that of that was absorbed and what went from there, but it gives us a chance to go from beyond saying, I don't know, it smelled bad and knocked him backwards, which is a qualitative exposure assessment, but not particularly useful, to having some sort of numeric approach to have this healthcare provider try to assess potential outcomes or potential treatments. There's another case, so that's an accidental exposure. It occurred, you couldn't measure it because it occurred and it was gone. This is an example of an exposure that took place 10 years ago, and they're worried about exposures that resulted in a health effect. In this case, it was a fetal exposure. A woman was working with spray paint indoors, and her exposures were below the exposure limits, but she was pregnant at the time. So you had 2 cans used over the course of an hour, about 900 grams. 85% of it was volatile, so you had 270 grams of volatile components being emitted over 60 minutes. So it's about 12,000 milligrams of volatile components a minute. That there wasn't a whole lot of air motion, so it was really just a diffusion into the surrounding airspace. And it's easy for me to say that turbulent diffusion is 3 square meters per minute. Finding out what this value is a bit more nuanced and difficult. But the concentration 2 meters from spraying can see would be up over 250 milligrams per cubic meter of the total solvent. Now you can apportion that into the different components of the solvent, because usually it's a mix. But an example of how a spray painting operation occurring 10 years ago with the MSDS, some information about turbulence in a room, some estimates of exposure can be made. And the models, these are just a few examples, and all models vary in complexity from zero ventilation model like the ethyl ether in the lab example. You can have well-mixed rooms. Rooms typically aren't well-mixed, but sometimes they are, and it makes sense to take that approach. You can look at multiple zones in a room. You can use diffusion. You can use a statistical technique called Markov chains and computational fluid dynamics. But the thing that you note if you get into this, the more complex the model, they're trying to represent reality more closely, it's harder to get some of that information. But you want to get parameters that are precise, but if you need input parameters for, say, a diffusion model, it's hard to determine diffusion coefficients, for example. And they may be imprecise themselves. But you want to use a model that's complex enough to answer the question that you're posing, but it doesn't always have to be super complex. So, for example I give is, if I do some modeling and the average concentration that this worker is exposed to is 15 parts per million plus or minus 10 parts per million as a 95% confidence interval. That's really uncertain. That's a really wide confidence interval. But I'm 95% certain that the exposure as a long-term average is between 5 and 25. Is that useful? Well, it depends. If the occupational exposure limit is 200 parts per million, that's a useful model. I can say that I'm satisfied that this is a low-risk exposure. If the occupational exposure limit is 20 parts per million, I'm less confident. And then I might want to supplement that. This is maybe one that I do want to go sample or do a more refined model. Modeling will never say don't sample if you can, but it'll help you be wise about what you do. And just a note here about new approaches through computing power to solving the models. A traditional approach was what we call the deterministic approach. I have a generation rate, I have a flow rate, and I can predict my concentration of 25 milligrams per cubic meter. But if I were to say that it's 500, but the standard deviation is 50 milligrams per cubic meter, and the ventilation rate averages 20, but it ranges between 10 and 30 cubic meters per minute, I can get actually more powerful outputs. I can say that the mean is about 25, and this is my estimate of the exposures that occur. The mean's about 25, the standard deviation is about 9.4, and 95% of the exposures are below 47 milligrams per cubic meter. This is an approach that you can do very straightforwardly on a laptop. And the advance of some real simple approaches to computing allows us to make even more powerful statements. Like, many people would not think that if I have a normal distribution of generation rate and a uniform distribution of ventilation rate, that I would end up with a skewed distribution of exposures. But that's what happens. And this helps us visualize the kinds of exposures and the patterns of exposures that can be occurring in workplaces. So what's the value that's added by modeling? There's lots of business case reasons to consider adding modeling. And I've gone over all these, and these are just reiterations of some of the main points. In some cases, a model alone can be enough to judge exposure acceptability. The industrial hygienist, with a 15-minute interview with an instructor and a little bit of time measuring ventilation, was able to say that ethyl ether exposure in that laboratory is not high priority and it's probably low risk. And he didn't just say it, he documented why he thought that was the case. You can maximize your monitoring budget. You can know where you're going to get the best bang for your buck when you're doing monitoring. So if you can document the exposure is likely low, you probably don't need to do some monitoring. If you do some modeling and the exposure clearly is high, start controlling before you even bother monitoring. If you're in an unknown area, maybe that's where you want to prioritize your monitoring efforts. So you can draw stronger conclusions from fewer samples and prioritize what you're going to do. Models give us quantitative support for qualitative exposure judgments. There's this idea of professional judgment that's been out there for years. And in the introduction to this book, John Mulhausen, who's with 3M, makes the case that if you're an occupational hygienist, you're a modeler already. If you see a well-ventilated room and you see a low-toxicity compound that's leaking at a very low rate, and you say that's low priority, that's a model in your head. But that's not a documented model in your head. 15 minutes on paper, you have documentation that that's a low priority exposure. Can save money, which is always very important. Again, anticipating exposures from process changes. I gave that example where you're going to put in this degreasing process. I know of industries that selected a space for a process, put a process in, and then had to retrofit almost $1 million of exhaust ventilation to make that safe for workers. They could have, 1, chosen a different space, 2, chosen a different process, and 3, if they still wanted to put it there, retrofitting is always more expensive than putting it in the first place. And you can also use modeling to increase your confidence in accident and emergency preparedness and evaluate the effectiveness of proposed controls. If you're going to spend money on a new ventilation system or a process change or a raw material change, you can predict ahead of time what that's going to do to exposures. And going back, fill in data gaps we have in historical exposures, be it for epidemiology, be it for completeness in corporate records, be it for defense against litigation. So I thank you for your attention. I am always interested in discussing these things. If you'd like to discuss potentials or scenarios or any help that I can give, feel free to contact me. Or again, any of the other authors in this book would love to share their passion and their expertise in this. If you're worried about dermal exposures, talk to Jennifer Sammel. If you're worried about applications with this in Bayesian technique, talk to Paul Hewitt. There's a lot of good people put a lot of good time and effort in that, and they'd all love to help you if you're interested in integrating mathematical models into your practice.